Good morning, everyone, and welcome to this webinar brought to you by the Streaming Video Alliance on measuring and optimizing perceptual quality in online video. My name is Jason Tebow. I'm the Executive Director of the Streaming Video Alliance. If you're not aware about our organization, we are a global group that has come together, spanning companies across the video ecosystem to solve critical challenges in the streaming video space and provide guidance and specifications and best practices to help companies make a better online video experience. With me today, I have four really fantastic people from a number of Streaming Video Alliance member companies here to talk about this concept of perceptual quality in online video and sort of how do we optimize it, how do we measure it, how do we make it better, what are the challenges, et cetera, et cetera. I mean, these guys are the experts in this field. And so what I want to do right now is I want to go through each of them and let them introduce themselves. Just before I do that, a little bit of housekeeping. We will be recording this webinar. So if you have colleagues that couldn't attend or you want to share it with somebody else, we will be sending a link out to everybody probably tomorrow with information on how to watch the on-demand version. And again, if you have any questions, remember to please use the GoToWebinar tools and ask the question at any time during the webinar. We will try and carve out some time at the end to answer all of your questions. And if we don't get to them, we'll try to get to them after the webinar. With that said, let's introduce our panelists. If we can start out with you, Gill.
Hi, my name is Dror Gill, and I'm the CTO and VP product at Beamr. Beamr is a leading provider of video encoding and optimization solutions to global MSOs, telcos, and OTT streaming providers. We have both encoders and transcoders for H.264 and HEVC, and we've developed some patented technology for content adaptive video optimization, which reduces the bitrate of video streams without compromising their perceptual quality. This technology is based on a very unique quality measure, which accurately quantifies the subjective quality differences created by the video encoders.
Fantastic, thank you, Dror. Next, we've got Thierry from Harmonic.
Hello, everyone. I'm Thierry Faultier, Vice President of Video Strategy at Harmonic and also President of the Ultra HD Forum. Harmonic is the leading video technology provider for video delivery, and we have been pioneering the ContentAware Encoding for several years now, and we are very happy to share with you our experience in live commercial deployments, and I'm quite happy to be part of this panel today.
Fantastic. Thank you, Thierry. Next, we have Dr. Abdul Rehman from SSIMWAVE.
I'm Abdul Rehman, CEO of SSIMWAVE. We provide enterprise-level software-based solutions to measure and optimize viewer experience throughout the delivery chain by modeling the human visual system. We are the original inventors of structural similarity index that I believe most of the folks on this webinar are familiar with. That is the most cited work in video engineering ever. We won an Emmy Award for that. We have the most cited work in video engineering ever. Now, after 15 years of work on top of structural similarity index, we provide the most accurate and complete video quality metric that has been independently tested using publicly available data sets.
Fantastic. Thank you very much. And last, we've got Charlie Dunn from Tektronix.
Yeah, hey, thanks, JT. This is Charlie Dunn. I'm the general manager for the video group at Tektronix. Tektronix is a long-term provider of test and measurement equipment to a much broader industry. I run the team that is really focused on media and entertainment, where we really focus on quality, compliance, and service assurance measurement across all the way from content creation all the way to delivery.
Fantastic. All right. Well, let's jump into questions then. So let's start out with something maybe not as technical as you guys can probably delve into, but something that's a little bit more high level. And really, I want to get to this idea that, how much does visual quality of streaming video really play into the overall user experience? I mean, do users really care that it's, a super high quality video, or are they satisfied with something maybe a little bit less as long as they get to watch the content? And actually, let's start off with Dror. Why don't you give us your thoughts on that first.
So it really depends on the context of viewing that video. If it's some pirated content that you downloaded and you have no other way to see it, then you will be satisfied with the quality that you get, as long as you can see that quality that you want to see very much. But today, for all of the licensed content and the legal content, you have various ways in which you can watch it. It is available on various types of services, whether broadcast or on demand or over the top. So for those type of services and for this content, you would want to choose a service that provides you with the highest quality possible, and it is quite easy to compare between them. If you look at traditional broadcast, this has pretty much deterministic quality, unless you have some severe weather conditions, and then traditional broadcast and even more than that, satellites can be compromised. But usually the quality is consistent and it is a high quality. So when people view similar content on alternative delivery methods, such as over the top, they expect to have the same stable quality. They don't want to see any buffering. And of course, they don't want to see the stream stopping in the middle. This is an experience which is not good, and it is part of the video quality. So it's not just the encoding quality, the quality of the pixels, artifacts that appear in the video, but also the smoothness of the video and how it flows over the channel. All of this comprises of the user experience in terms of visual quality. And I think that consumers today are very picky about the quality of the video that they watch.
Anybody else want to add to that?
Yeah,
I would so I agree with Gill on a few points. As you know, there are two parts of the story here: the content side and the quality side. So 100% agree with him on that. And also expectations from viewers' perspective in terms of what they would like to see. And some customers or viewers are more picky than others based on what sort of content that you're watching. So what that calls for is a quality first approach, because if it's relative to that specific viewer, you do not want to disappoint that specific viewer. So if you have an understanding of your experience and you can control the quality by using a quality first principle and starting from the end viewer in mind, then you can actually satisfy the demands of viewers across the board. So that's one. The experiences that we have through deployment with one of the largest MSOs and other MSOs, the broadcasters typically have a more consistent quality, but over the top has the capability to go sometime beyond that, because sometimes they do not have those restrictions. But certainly broadcasters have the capability to deliver it a lot more consistently to viewers. Now, there are two parts here. There's the delivery side and there's the compression side. Both sides are important, and it needs to be determined based on psychovisual behaviors of the human visual system and the content itself, viewing conditions, display devices, to determine what part matters the most before deciding how to optimize.
Yeah, hi, this is Charlie. Yeah, I think I guess I'll agree with the last point, which is I think there's an opportunity in the long run to provide a better experience. I would say today it's about matching what a good broadcaster can provide. I think that's the bar for a lot of OTT services, and it's maybe not so much about the encoder itself, but it's how consistent the bitrate is being delivered to the user, or what bitrate they're pulling down. But I would like to highlight that for most service providers, it's about optimizing the most efficient encoding scheme. So the lower the bitrate can be, the more consistent it can be delivered. So just the same as it was in broadcast, it's all about efficiency. So if you can balance the, how efficient can I make this versus how good can I make it, that's really the balance that most service providers are really dealing with, and how far they can squeeze it down to where they can still deliver good quality and match the brand that they expect, but also they're being efficient so that they're delivering a consistent service.
Okay. Let's shift gears a little bit. I'm actually going to pick on Thierry for this one because I've had some interesting conversations with content creators. And one of the things that they consistently say to me is, you know, listen, I'm an artist. I have a vision for what I want my finished product to look like. Not necessarily from story perspective and all that, but from a quality of video perspective, right? They've used certain camera lenses, certain filters, certain lighting. They have a definite image in their minds of what this end result is supposed to be. So obviously that we'll call that sort of the master copy. And then you have all these copies that are created from that master for distribution. So it might be, you know, on a Blu-ray disc, it might be, you know, an HD on-demand video, it might be SD live feed, whatever it is, you've got all these encoded and transcoded versions of that master copy. So how can a content distributor, so somebody who's licensing content from a content creator, how can they ensure, you know, through technology, through workflow processes, whatever, that the copies they create for distribution are as, you know, closely represent the master as possible?
Well, it's a very good question, Jason. I think I will have to pass on it because it's a question I think has been around for the last 35 years. I would like to defer to our quality of experience measurement partners, SSIMWAVE and Tektronix, and I will talk after that.
Okay, sounds good. How about Dr. Rehman? How about what are your thoughts on this?
Yeah, absolutely. So preservation of creative intent is extremely important. We work with cinematographers as well, and they have a working group that's named after SSIMWAVE. So we are very intimately familiar with the challenges that they have. So video content properties such as resolution, frame rate, dynamic range, human visual system behaviors, display devices, and playback conditions all really, really matter when it comes to that. Yeah.
Yeah, I'll add a comment. JT, I think while that's an intent for distributors, I rarely see people who are actually providing the service going back to them and checking quality for them. What I see more is those providers have to have a brand that they want to set a certain quality level. So for them, it's about making sure that they're consistent with whatever master they get, that they're delivering a certain or consistent quality level. And a lot of times the encoding process that they use may drop below that brand level. So how do they make sure that when they're transcoding it, they're not dropping below the own quality level that they set? And they have a lot of different tools that they can use. They can use full reference quality measurement like a VMAF, where you're essentially comparing the original to the subsequent encoded piece. That's a technique that's open source from Netflix, that they've provided that, working with USC. But in a lot of cases, for an operational provider, they don't really have the time to do this full reference check. So they want to use what's called a no reference quality check measurement, which is, if I don't have access to the master and I've just encoded it, how do I measure the quality of that? And that's really what we've developed inside Tektronix, which is called a TekMOS, which is a machine learning based technique that will allow you, without looking at the master reference, to make an assessment of that quality and have it be really accurate and really correlated with a full reference measurement.
Fantastic. So I think you, go ahead, sorry.
Yeah. So I'd like to add to that. So the approaches that are conventionally used in academia are reference-based, no reference, reduced reference, degraded reference, and we are the pioneers in most of these and have developed this right from the get-go. So the reference-based approach allows you to compare with that master in a way that you can measure the preservation of creative intent, but you want to make sure when you do that, you're not ignoring the aspects that I mentioned before from your experience perspective. So for example, what display devices are going to be used, what viewing conditions, because they would have specific master display that they would have in mind, but they would also have specific other displays that they would have in mind that they want this content to look exactly like they want it to be looked at. So change in resolution, change in frame rate, change in dynamic ranges. This is what cinematographers are really concerned about, because they believe that once the content goes out, then the creative intent is not preserved by the broadcasters and delivery providers. And in order to do that, you always have to compare against the reference. And that's where in a live environment, we provide a reference-based measurement, so you don't have to wait at all. We do automatic quality assessment of a master and the output that comes with it. That's transcoded output of that, automatically align that, and then follow that correlated measurement throughout the delivery chain. And we do take into account all the aspects that we talked about: video content properties, human visual system behaviors, display devices and viewing conditions, as well as playback. So this is the reason why you would want to work with a reference-based metric, because yes, you can do no reference quality measurement, but that defeats the purpose, because the cinematographers only care about their intent and what they have produced. So if you say that I'm not going to compare against that, I'm not going to use that, then that really defeats the purpose at the end of the day.
Yeah, I'll make one comment on that. I think it's really about the provider of the service that really cares what their customer experience is. There is a connection maybe to what the cinematographer wants, but it's really about what the provider has. And if you're talking about a provider who's processing thousands of pieces of content, for them it's about efficiency and making sure that they can do enough quality measurement to make sure that it's going to be meet their standards. But to do a full reference measurement on every piece of content that they have is another expense that they have to weigh whether or not that's worth it to them.
So Jason, maybe to give you some history, in the past, you had for SD MPEG-2 studios requested VOD to be encoded at 3.75 megabits per second. And if you talk about video compression, this is meaningless, because it depends the type of content, the type of criteria you use to basically judge the video quality. So this is why it's very important to have this type of no reference measurement. But I think the industry is also trying to reach a goal of having an assessment of the video quality. When you transfer the adaptive bitrate set, you would like to, for example, say to your decoder, this is a decent quality video, don't ask for upper profile. And I think those are the interesting conversations that are taking place in WAVE, where people would like to agree on certain quality levels so that the player would be more clever than only looking at the bandwidth on the network and not on the video quality.
I see you guys bring up, it's kind of funny, I think you inadvertently answered a couple of other webinar questions, but that's okay. You bring up sort of the meat of this webinar, which is around measurement, right? So one of the key tenets of the title was measuring. Obviously you mentioned VMAF and some other methods, but what about the experience at the player itself, right? Are there measurement tools that can be deployed in the players to capture what the user is actually seeing and experiencing versus maybe what's coming out of an encoder or transcoder, compared to the master copy? Is there anything like that in existence, and sort of, how does it work?
So if I may, because this is also on measurement, this has to be correlated measurement where you understand the impact of delivery on top of compression. So on the playback side, you have rebuffering, stalling, switching, startup delays, and other aspects that have to be understood together with any compression impairment that has happened on the server side. So it has to be correlated measurement, and there are approaches that MPEG- allows you to take advantage of to achieve that. And this is exactly what we do at SSIMWAVE.
So have you guys seen any really big deployments of this?
So there are independent measurements on the client side that ignore entirely the perceptual quality or the encoded content, and they focus on delivery impairments. But so far, no. But yeah, that's what we have been working on and working on launching soon. where we take both sides of the picture and tell the full story.
Did you have something to add, Charlie?
Well, I think, you know, the bigger providers of the, I would say, endpoint monitoring, Conviva, Nice People at Work, they, as they said, they're providing I would say, a light level of what the experience is of the user. I think maybe it's a matter of time before they do some picture quality elements. I would say once it gets down to the endpoint, I think it's really about whether they're getting the bit rate and whether they're able to pull down the right profile and other pieces. And that's really a bigger determiner of the end user quality rather than actually measuring the quality itself. So it's very expensive to measure the picture quality down at the endpoint.
So in order to overcome that, you can do picture quality on server side, and then you can deliver that measurement to the client side, and the client would overlay that to the delivery quality to give you the full picture. And that's what, for example, MPEG-ISO 23001-11 talks about. So you need a quality metric on the server side that's device adaptive. So if the server side metric is device adaptive and that can adapt to any display device and viewing conditions, then you have the capability to not only take into account the picture quality and shift the full load of computations on the server side, but add on top of that delivery impairments on the client side. So the client side component would be extremely light. So SIMplus is the only metric that does device adaptability. So you can actually do measurement for your OLED B7, or you can do it for iPad Pro, or you can do it for an iPhone 10, considering all the properties and viewing conditions, and do the measurement on the server side, so you would know what your asset is like, how good the quality of the encode is, and all the profiles are, and then you can send that data to the player, or you can store that in your database and have the player send back those events, and then combine these two together to give the overall experience. So we have written research papers where we see that when they're stalling, what's the picture quality at that point? And these aspects also matter, because you have to sometime make a decision in terms of whether to stall or go to the lowest possible bit rate that the channel can support at that time. And this is where a quality metric can be really helpful, because both sides are bad, and you are in the middle of a rock and hard place, and you want to make the best decision. So if there's no metric that can tell you how compression and delivery impairments compete against one another, then you cannot make that decision in real time. And this is why you need to have a metric that's a combination of both aspects and actually and truly measures the viewer experience for any device on the display side.
All right. So something you said, Dr. Rehman, is interesting. So you've got these two components of sort of visual quality that you can measure and obviously optimize at some point. You've got the compression side and the delivery side. So what I want to do right now is I want to turn a little bit to the compression side. And Dror, I'm going to kind of point this question at you, and then I've got a follow-on question for Thierry that you guys can both weigh in on as well. But how can content owners and distributors optimize the encoding process to ensure that, again, the perceptual quality remains as close to creative intent as possible? What can they do?
So it is obvious, I think, also to not only to the distributors, but also to the content creators, that the full quality of the content that resides on the studio side, on the mastering side, cannot be delivered to the end users. There are constraints and there are limitations. Some of them are because of the viewing device, but most of them are because of the network and the delivery mechanism, which is a constraint. You have to serve a very large number of users. And if it's over the top, they're all going over the internet. And you have to take into consideration the actual available bandwidth from the delivery point to the end user. So when you compress the streams, you would typically compress them to what's called delivery bit rates. These are the bit rates you would use to deliver those streams to the actual end users. And the typical way to do this until recently was to use the fixed bit rates, regardless of the content. So you need some sort of adaptive streaming. You need several layers of a video to enable a good experience, and then the user can select between these layers according to the instantaneous bandwidth. But these layers are typically chosen in a fixed way. So you can have, let's say, a full HD at 3.5 megabits, 720p at 2.5 megabits, etc. And that's the easiest way to encode. The problem with this type of encode is that you are not utilizing your bandwidth in the most efficient way, because some of the content requires more bits to preserve good perceptual quality, because it is, what's called in video encoding difficult content or complex content, if you have a lot of motion, a lot of detail. On the other hand, there are some types of contents which are easy to encode if you have not a lot of motion, a talking head scene or something like that. So if you use the same bitrate for all type of content, on some content you won't deliver enough bits, and on other content you will deliver more bits than needed. So the trend today, and this is something that we started 7 years ago, is to do content adaptive encoding, is actually to take each piece of content and to set the bitrate according to the content in the optimal way. So you allocate the optimal number of bits for each piece of content, and in this way you ensure that the maximum quality that can be delivered over a certain channel is delivered at any given point in time.
You guys have anything to add on that, Thierry? I mean, I know that you guys are doing, context-aware encoding as well. What are your thoughts?
Yes, so the good news is that the industry has agreed on this content-aware encoding definition. And you know that iOS 11 has specified for VOD and for live VBR encoding. And of course, it's up to the encoder company to decide how the bits should be allocated. Netflix is doing that for many years with their per title encoding. And as Dror said, they can change the resolution, they can change the bitrate per scene. It becomes, of course, interesting when you have to do that in real time. And as you know, it's a bit of a challenge to change the resolution of a profile in real time. The decoder might not like it. So what we do in Harmonic, we are modulating the bits we allocate for each sequence in real time, and we try to take advantage of the complexity of the content. So difficult content is going to be a higher bitrate, easier content, lower bitrate. As a matter of fact, American football is very easy to encode because there's so much advertisement that you can have a lot of relaxing time to put less bits during the ads. This is a side joke. But as a matter of fact, so as I mentioned, Apple, very important, iOS 11, Android still missing in action. Ultra HD Forum members have recognized that this was an important technology. And I think all the vendors that were part of the NAB booth were showing UHD encoded in CBR at 25 megabits per second and the same content, similar quality. And we'll come back on what is similar quality. We're able to show content-aware encoding at 15 megabits per second, which is a 33% saving. And this is what is interesting for operators, for content providers and service providers who want to deliver the content. The best kept secrets is Netflix who's telling you need to have 25 megabits per second connection to receive UHD HDR. And when you look at the ISP average bandwidth, you see that this is no more than 4 to 5 megabits per second, which means that people are going to watch HD. In order to reach this holy grail of 4 to 5 megabits, you need to compress, of course, in a very efficient way. And content-aware encoding is one of the tools to reach that goal. The other tool that people are starting to look at is what we call artificial intelligence, where you are basically teaching your live encoding system to encode with a special pattern. And then when the real-time encoding is coming, you can even decrease additional bitrate by applying machine learning techniques. And we were showing some prototypes at NAB on a live system that can even further reduce the compression, still keeping the quality target, which means the CBR encoding at high bitrate. So as you see, there are many tools. We, of course, are not interested to sacrifice the video quality. We are interested to keep the best visual quality. And of course, all the secret sauce is about how do you measure in real time the quality in your encoder and how you can interoperate with all the players on the planet. As I mentioned, HLS, we can cross-check that. ExoPlayer supports ContentAware encoding, but it's still not the ubiquitous player for Android, and we expect Android to have soon a specification that will support ContentAware encoding.
Fantastic. Anyone else have anything to add on that?
So what I would say there is we should use quality first principle. I think we say the highest quality we need to deliver. I think we need to start defining that quality. We need to say it's an 80 or an 85 or a 90. I think video has become so popular that it's not good anymore to say highest possible quality. It's to define the quality is what we need to start doing as an input to the systems.
It would seem to me that the phrase highest quality possible is really a marketing phrase because obviously, you know, end users are like, oh my gosh, it's got to be the best they can possibly deliver, so I'm going to watch it. So that's very interesting. Let me switch a little bit here because you guys have touched on this individually across a number of questions we've talked about this morning, and that's around you know, the screen itself, right? So screen size or device type. But, you know, how does multi-platform viewing, which is obviously very popular now with people moving between devices to watch content, how does that complicate the process of optimizing encoding and transcoding to maximize perceptual quality? So in other words, does screen size matter when talking about maintaining perceptual quality? And why don't we Charlie, why don't you jump in on that one first?
Yeah, sure. I think certainly it makes for a more complex environment for the operators. At least on our side is how do they ensure that every service they provide and every profile is doing a good job. You know, many of them have asked for ways to sample or to pick off one or two profiles as a proxy for the whole system because they're really trying to deal with the practicality of trying to measure the quality or just the service assurance across all of those. But I would say the screen size absolutely matters. So when we do a no reference quality measurement, it really has to be based on, well, what kind of screen is this going to be displayed at? Because a mid-level bit rate may be perfect quality for a mid-sized screen, whereas a high-level bit rate may be complete overkill. So for us, we would always try to score it based on what the target screen device is.
Other thoughts on that?
So since it's content dependent, and we heard the football example where the complexity is changing, the impact of the content and the quality based on the screen size changes dynamically together with that. So there are extremes of content. So for example, on one side you have screen content that's very complicated for you to keep good quality for because it has really sharp edges and human beings are trying to read text. But on the other hand, you have really simple content as well. In the middle, you have the natural content, if you look at the spectrum of the content types. So it really depends on what content is being streamed across these different devices. So let's say behind the router, you have 4 or 5 devices that are watching different sorts of content, and you have the opportunity there to trade off bandwidth between them based on what sort of content they are watching, what sort of device they are using to meet the target quality across those devices. And there are opportunities working with the industry that has cables going into the homes, and they can control certain things. And then for the other parts of the industry where they cannot do that, you may have that information available on the server side, and you can do a joint optimization, solve a joint optimization problem where you can see that, okay, there are 2 cell phones, 2 tablets, 2 TVs. These are the content types that are being watched, and this is how we can normalize quality across them or meet the target quality levels or define rules in terms of how would we do that. All of that would not be possible if you do not have an accurate quality metric that exactly measures viewer experience on those devices in real time. That takes into account perceptual quality from compression impairments perspective, impact on perceptual quality due to compression, and delivery. And then you have this, like I said, joint optimization problem to solve, and say that how do I manage the bottleneck that I have from where the video is being streamed to this home that has multiple devices that are watching content. So there are multiple opportunities for optimization here that I touched on, but the key to unlocking all of these opportunities is the availability of a quality metric that exactly tells you your experience across all these devices in real time.
Fantastic. And Dror and Thierry, you know, taking a step back to the previous question around, you know, content-aware encoding, what are you guys doing from the encoding side to really address this, you know, this problem of, you know, differing video screen sizes, differing device requirements? Obviously, you know, what are there any technological things you guys are doing which will help, you know, content distributors or content owners sort of maximize the perceptual quality when delivering to multiple devices?
I think, sorry, yeah, go ahead.
Well, I mean, this is a very broad question, but Jason, let me give you an example. For example, when you encode 1080p 60, you know this is targeted for TV because most of tablet cannot catch this resolution, and the player will probably not go that high because he knows he has limited capability, limited CPU, limited screen size. So 1080p 60, we pretty much know this is going to go to a TV. 1080p 30, a TV is not going to be very keen on set-top box to use this format because for broadcast quality, this is not the right frame rate. So we know this is more falling into the tablet, the PC, or the mobile. And then the lower resolution you go, the less you want to present that on a TV. And you know that, for instance, the sweet spot of a tablet is 720p 30, the sweet spot of a mobile phone is 480p 30. So you have already some golden operating points. Now, what we try to avoid is the player to go at a much higher resolution because sometimes it's useless for the screen size and the distance of viewing distance. So I think you can do very pragmatic rules on the player side, and this is not rocket science from my perspective, but maybe Dror has a more theoretical approach to the problem.
I think it is could be quite dangerous to put too many assumptions on the device based on the stream it receives. Today we have mobile phones that have 4K resolution. We have tablets with 4K resolution. And the players on those devices, if not instructed differently, will pull the highest quality stream that they will be able to get. On the other hand, I wish that every TV in the world displayed Netflix in 1080p. In some places, there is not enough bandwidth, so those streaming devices who access the Netflix service are pulling in 720p and sometimes 480p streams and expanding the resolution and blowing it up so it can be viewed on the big screen. And I think this poses a real challenge because when you compress the stream, you need to take into account all of these different viewing conditions that can happen. Obviously, if you're viewing 4K on a phone, you can mess up the pixels really bad, and the pixels are so small that nobody will notice. On the other hand, if your 480p stream goes to a TV, you want it to be a very high quality. And I really think this is a major challenge, and it really depends on the service. The service providers know what percentage of their users are receiving each type of stream because they have the statistics from the player and the server that streams those ABR layers. So they can really optimize the encoding based on what is actually perceived by the majority of their users.
Okay. All right. Let's talk a little bit about a topic that you guys have all addressed during this webinar, and some way, shape, or form. And that's, machine learning and artificial intelligence. So obviously there are different ways to apply this technology. It's still very, very, very young. We're trying to figure out its applications and its implementations. But, you guys have talked a little bit about using AI and using ML to impact, the way content is both encoded. So, again, referencing, the two sort of ways that Dr. Rehman talked about, the perceptual quality, sort of the delivery and the compression. So obviously the AI and ML can be applied to compression and encoding. We talk about that content-aware encoding, but it can be also applied to, delivery in some way. So I kind of want to open it up to a very broad discussion about these technologies. How can they be applied to, to again, either measure or optimize this perceptual quality? And let's start with Dr. Rehman.
So you have to be very careful when you apply machine learning. It's double-edged sword. You have to, instead of just using the AI and machine learning jargon and say that this is something that can be used everywhere, from a measurement perspective, you need to have measurements from maybe millions and millions of people before you can say that I can understand exactly how this complicated part of the human brain that perceives video quality, I can model that successfully across all different types of content. But having said that, going to vision science and understanding how human visual system works and the psychovisual behaviors gives you a great head start, and you do not want to throw that out. So if you use neural networks and you say that, okay, I'm just going to throw the pixels to the neural network and let the magic 8-ball decide what the quality is, that's not the scientific approach that we have been working on for the past 20-25 years. Our approach has always been understanding the human visual system, understanding the behaviors, psychovisual behaviors of the human visual system, and then apply machine learning where it does make sense. Because if you look at the permutation and combinations of the variation in content and the delivery systems and the video properties and the display devices, you would end up with millions and millions of combinations. And then to get that rated by a significantly number of people, and then to use that as learning, I see that. But if you have 30 sequences and you get those rated by 20 people each, and then you think that I can train my model based on that, that does not work. So it has to be done very carefully when you do that, and you have to model the parts of the measurement engine that would give you that prediction accuracy that you're after. But if you don't have the ground truth that we are looking for, that is the subjective quality at that scale, then you are just hoping against the hope actually there. The second part, as far as modeling the encoding engines are concerned, since we know what standards are out there, and you have to have bit streams complying to specific encoding standards, and you have the standardization bodies that go through this rigorous process of understanding performance of different tools that they introduce, and you have rate quality curves, and you use rate quality curves to compare against them. You have the capability to actually pass certain stimuli to this engine that's in the middle and observe what the engine is doing at the other end. So there are three parts to this problem. You have the content side, you have the compression side, you have the quality side. So if you know the two sides, that's the content and the quality side, you can solve for the compression side based on machine learning, and then make the best decisions for that box to deliver the optimal experience. So one last thing I would say is it is very difficult science. Retina display was the term coined by Apple, and that was just one outcome of this difficult science of viewing on specific display devices, and they sold a whole lot of phones just based on that. So let's not just make high-level assumptions in terms of what can be done and what cannot be. Let's leave it to a quality metric that's very accurate, and have it decide for you in real time.
I agree with Abdul regarding the human aspect of it. This is something that is unique to video. If you talk about subjective quality, true subjective quality, the only one who can judge that subjective quality is an actual human. And now the question is, how do you bring those humans into the loop and help you make the right decisions and help you optimize your algorithm? So what we have done, we use a lot of machine learning for optimizing our parameters and finding right thresholds. But when you actually need to calibrate the algorithm of the machine learning, you need actual user results. So what we did is we developed an internal tool which we called Vista. It's a visual system for testing video, subjective testing. And this actually automates subjective quality testing. So with this tool, we can deploy overnight a new version of video to hundreds of viewers. We're using a platform called Amazon Mechanical Turk. It's like Amazon EC2, but instead of scaling servers, they scale people. So you can solicit a task to as many people as you want, and they will view using our software 2 videos and tell you which one is better. And they will tell you which compression parameter, which threshold is better for the human eye. And based on this, after we feed this input into the machine learning algorithms, we calibrate the parameters of our encoding. But after this calibration, the encoders can run in real time and adapt the content, adapt the compression to the content that is coming in live, because they have all this experience that was learned from testing with hundreds and hundreds of actual human viewers.
Yeah, no, I think that's.
You know, this machine learning is going to occupy all of us for the next coming years. So my recommendation for the listeners is read the papers published at the conference. There was one very good at San Francisco PCIS. There will be IBC. There will be demonstration. Don't trust too much the show floor demonstration, and trust more your own evaluation. Trust more the paper we have gone through peer reviews, and you will see, like the self-driving car, when this industry started, I think about 10 years ago, nobody was believing it was possible. Now we believe machine learning works. It's not perfect. It needs millions of miles to drive a car properly. But guess what? We have a lot of computation power and more brains to drive all those algorithms. So if you see what I mean, don't judge too much on the words. Watch the video and read the papers and come to conferences.
Yeah, I'd like to add too, JT, that we've headed down this path of using machine learning for picture quality, and it's around our algorithm that we call TechMOS. What we were really after is a no reference quality measurement, which inherently matched what we could get from machine learning. I think it's a path that we've headed down. I think ultimately what we've found and become convinced in is that this can be scaled and be very efficient. We've measured it versus full reference quality measurements, some of our own, which through the Tech PQA, as well as VMAF, and we think it correlates quite well. I think the nice thing about it is as we put the model into use and as we learn more and as we train the machine more, it's only going to get better. So one of the challenges we had with previous methods is that new compression schemes or different kind of edge cases would break the model, and we'd have to go back and rethink the model. Here, those edge cases and different compression schemes only improve the model's accuracy. So for us, we've put it into our VOD product, which is Aurora, and we're adding it now to our live product. And I would say one of the main things, especially for OTT, is around customers' budget. The customers really have to think efficiently about how they're providing these services and how they measure across all of the services they provide. So for us, our take on using machine learning is how can we really efficiently provide meaningful quality information on all the live streams that the customer has and give them a reasonable accuracy so that they know that they're delivering good quality and they can worry about the thousands of other things they have to worry about in their operations.
Okay. Thinking about that a little bit, do you feel what are your thoughts on timeline where maybe machine learning and artificial intelligence are a bit more mature in how they're applied? And this is going to lead into the next question I have. Is it 2 years, 5 years, 10 years, 50 years? What are you just your general thoughts? And you can just chime in with like, hey, I think that's going to be, in 18 months we're going to see much more application of AI towards this problem of perceptual quality.
I mean, for me, it's probably on the order of one to 3 years. And again, I think the job of machine learning, certainly in terms of what we do, is making our operations jobs much easier than they are today. And so whether it's perceptual quality, or whether it's AV sync, or whether it's detecting that there's some other problem, I think machine learning can be applied to all of those things and give our operations teams better and faster clues as to how they can resolve the problem or how they can avoid a problem. But again, we've had so much success with TechMOS and how that's worked, and we're really just getting started with that. And I think I really like the comment about the digital Turk, because one of the challenges, as was said earlier, is you have to train the machines with many, many images, but there's so many ways to automate that now that we're just finding and exploring those ways. And so I think that's going to accelerate over the next couple of years.
So when it comes to modeling a machine, you have that coming faster because machine is made by people. When it comes to modeling the human visual system, and as we know in biology as well, we are trying to understand the human visual system. It's going to come later. That's going to come when we have enough, quote unquote, enough. As a scientist, I would like to use exact numbers. So that's why I'm saying, quote unquote, enough number of observations available to accurately model the human visual system. I think we have led that path in terms of doing quality assessment based on machine learning. We have written many papers that are very well cited using convolutional neural networks and many other approaches that are out there in one of the best journals, like the Transactions on Image Processing and many of those. So you definitely have to explore the option, but to actually say that the machine learning would replace the human brain is too early. Having said that, let's continue working towards that, and maybe in 4 to 5 years we'll be at a point where we can say that the machine can replace the human brain, the visual side of the human brain.
Okay. So as I said before, I think this is going to lead me into this other question. It's actually a question from the audience, so it's kind of a nice segue into answering some questions from everyone out there who's been participating in this webinar. Obviously, machine learning, artificial intelligence are changing technologies right now. They're going through iterations and evolutions, and no one's really put sort of pen to paper to say this is how it operates all the time. This is the way it should operate. The same thing could be said around perceptual quality, right? So, Charlie, you talked about Tektronix, TechMOS. Dr. Rehman has talked about work that SSIMWAVE has done over the past 15, 20 years. And Thierry and Dror have mentioned sort of proprietary methods that their companies are using to ensure high quality, high perceptual quality. So, are there any standardization efforts that are out there, currently being worked on around optimizing, the perceptual quality of visual or measuring the perceptual quality of visual? Is there any efforts underway right now that people can sort of go to and use that as at least a springboard to implementing the way they should be measuring or optimizing it?
So International Telecommunication, ITU, sorry, please go ahead.
No, go ahead, Dr. Rehman, that's perfect.
Yeah. So ITU actually has many committees, and they have been working towards standardization of quality measurement for many years, at least 20 to 30 years, if not more than that. They invite proposals from different parties, and similar to how they standardize the compression side, the compression standards, they work on quality measurement as well for different applications. And there are standards that you can go and find. I'm happy to talk about some of those if there are further questions. Now, these standards, just a couple of other things. These standards are coming out since 90s, but there's nobody now at this point that talks about those standards. Just the question itself shows how ineffective those standards are. Having said that, in 2003, when we invented Structure Similarity Index, that has now more than 40,000 citations. So the question that we had when we started the SSIMWAVE and we started providing SIM Plus Index was to actually go and standardize that, or do we really want to support this and make a change, bring a change towards how video is delivered. So based on our previous success and standardization bodies not being that successful, we followed that out where we really want to work really close with the industry and bring the awareness of video quality measurement in real time for live and VOD environments, and then optimize on top of that. But yeah, there are standardization efforts being done throughout.
But still, the question is very relevant, because those standardization efforts have not produced a single standard for video quality that is used across the industry. And I think there are many interesting reasons for that. You know, I've been working in the SVA, in the video quality group, and it was very difficult to come up with a definition of video quality, user experience, things like that. And I think measuring quality of delivery, or measuring compression artifacts, or measuring errors in the bit stream, how they affect quality is really different. And it's very difficult to come up with a single method that can cover all different types of errors, artifacts, and quality degradations that can happen to video. So that's why those efforts, I think, until now have not been successful. And that's why we've developed our own quality measure, which we used internally in the compression process, because it's not something general. It's a quality measure we've optimized to detect and quantify the artifacts created by block-based compression. It's very specific to that purpose, and it's for that purpose it is very efficient and accurate, but not for general use. So I think the industry is still looking for something that everybody can settle on. It might have been VMAF, but that did not happen yet. I think the industry is still looking for something that can be used in all cases, but maybe such a quality measure doesn't even exist.
All right, fantastic. Well, actually, we are out of time. This has been a fantastic discussion, guys. It's you know, you covered a lot of topics and a lot of ground, and you know, obviously, I think this is an area where content owners and distributors and everybody in the ecosystem can, you know, is probably still going to be working for years to come up with not just a standard way of measuring and optimizing, but, you know, a way of implementing, right? How do we implement technologies that a lot of your companies are offering in order to improve the user experience? Because that's really, you know, what it's about. Yes, we want to make sure that we maintain creative intent, but I mean, if we all want this to be a business, we have to make sure that we're pleasing our end users. So for everybody out there who was listening, if you asked a question and we didn't get to it, I will try and have that question answered for you via email. Again, a link will be sent out in the coming day with an address to watch the on-demand version. So obviously you can share that around to anyone who you think might benefit from the discussion that ensued. Again, thank everyone so much for attending, and we wish you a wonderful rest of your day, and we will be in contact soon about our next webinar in July. Everybody take care, and bye for now.
Yeah, thanks, JT. That was great. Happy to be on the panel.
Thank you.